All right, we've talked about two methods up until now. We've talked about tiles, which is modeling. We've talked about the box, which is it's like an organized visual distribution, a visual representation of the tiles. Today I'm going to teach you the final method for multiplying. Well, there are others, but the final method we're going to learn this year, which is called algebraic distribution. So what that means is we're basically doing the box without the box. So I'm going to do an example of using the box, and then I'm going to show you what that looks like using this other method, algebraic distribution. Your parents may have heard of this method as FOIL, which stands for first, outer, inner, last. And it's a way for you to remember which terms you need to multiply together. Algebraic distribution is actually not my favorite method, even though it's the one that I learned and the only one that I knew before I started teaching algebra. I don't like it as well as the other one because I feel like the box is organized and it scales. So if I have like a 2 by 3, I have an empty box for every set of terms I'm supposed to multiply together, so it helps me keep track of what I'm doing. But again, whichever method you feel most comfortable with, you have to understand all of them, specifically the box, because we're going to use that in the next part of this unit when we start to factor. But as long as you understand all of them, as long as you understand every method, you can choose whichever method you'd like to use from now on. So let's try an example. So if I had this, x minus 6, x minus 2. Okay. If I was solving this using tiles, I would draw a bunch of tiles, and I'm not going to do that. If I was solving this using the box, I would draw a box, and I would put one of them on the top, one of them on the side, and then I would multiply each thing together. So x times x is x squared, negative 6 times x is negative 6x, x times negative 2 is negative 2x, negative 6 times negative 2 is positive 12. And then I would combine them all together. So that gives me x squared minus 8x plus 12. Okay? That is the box. Now let me show you what this looks like when we use FOIL. So I take my x minus 6 times x minus 2. And I remember when we would distribute, like if we had 2 times 3x plus 7, we would draw an arrow to tell us we do 2 times 3x and 2 times 7. Well, we're going to do the same thing here, except we're going to multiply everything in the first one by everything in the second one. Okay? So I'm going to multiply my first terms together. So x times x is x squared. I'm going to do my outside terms together. X times negative 2 is minus 2x. I'm going to do my inside terms together. Negative 6 times x is negative 6x. And my last terms together, which is negative 6 times negative 2, which is positive 12. And it looks like a little bald dude with a comb over. See, there's his nose, and there's his mouth, and there's his ears, and there's his comb over. Anyway, whatever, the little bald dude. Okay, so now I'm going to combine my like terms. Well, I have negative 2x and negative 6x. So I start with my highest order exponent, x squared. Negative 2 plus negative 6 is negative 8x plus 12. I get the same exact answer. So it's the box without the box. See, I had an x squared, I had a minus 2x, I had a minus 6x, I had a plus 12. Just instead of them being in the box, they're in a line. Okay? So that's the only difference. Basically, again, algebraic distribution is the box without a box. Okay? And this is like the old school method that we all learned when your parents say, we didn't learn it with this box, this is what they meant. This is how we learned it. Okay? So let's do a couple more examples so you can kind of, get some practice, because you are expected to know how to use this method. I don't expect you can pick whichever method you like, but you have to know how this one works, because they may ask you, this is one of the processes that you're expected to know, and the state of Texas may ask you a question about how you use this process. Okay? So let's try another one. Okay? 2x minus 3 times x plus 1. Okay, so I'm going to do this one with FOIL, and then in a minute I'm going to let you try one on your own. Okay, so again, I'm going to do my first terms together. So 2x times 1x is 2x squared. My outsides, 2x times positive 1 is plus 2x. Negative 3x times 1 is, well, negative 3 times 1x is negative 3x. Negative 3 times positive 1 is minus 3. And then I combine my like terms, and I get 2x squared minus x minus 3. Okay? I want you guys to try one now. I want you to try 2x plus 7 times x minus 1. And what I'm looking for is a final simplified trinomial. Go. Okay, so I'm going to start working this one out. I have 2x times 1x, which is 2x squared. 2x times negative 1 is negative 2x. 7 times 1x is plus 7x. 7 times negative 1 is minus 7. When I combine my x's, I have 2x squared plus 5x minus 7. Okay? Now there's two other ones, and I want to talk about these just because you had a couple of, like, y'all had a little bit of, like, what? On your homework about these, so I want to talk to you about them. Let's look at this one. X minus 4, x plus 4. Okay? This is a special, these two have a special relationship because I have x plus 4, x minus 4 is a special, it's going to result in a special product which is called a difference of two squares, and you'll see what that means in a minute. Let's FOIL it. Okay, we have x times x is x squared. 4 times x is plus 4x. Negative 4 times x is minus 4x. Negative 4 times 4 is minus 16. Now what's special about this when you have the x plus 4 and x minus 4 is that positive 4x and negative 4x, they cancel away, leaving x squared minus 16, which is called a difference of two squares. We'll spend a whole day on this. It's a difference because it's subtraction. X squared is a perfect square, 16 is a perfect square. So it's the difference of two squares for this one. Now I talked to you about this one in class, so hopefully you can figure this out. I want you to try this one. X minus 2 squared. Solve that one. Take a minute. Okay, so for this one, when we see something squared like this, your instinct is to square this and square that and put whatever signs in the middle. So your instinct is going to be x squared minus 4. That is wrong. Do not follow that instinct, okay? What you need to do is immediately expand that. Okay, so immediately expand it out. And now you see you have two binomials. Well, x minus 2 times x minus 2, x times x is x squared. Negative 2 times x is negative 2x. Negative 2 times x is negative 2x. And negative 2 times 2 is plus 4. When I combine my terms in the middle, I have x squared minus 4x plus 4. This is called a perfect square trinomial because this trinomial results from multiplying a perfect square. Okay, and again, we're going to spend time talking about these two cases a little bit more later on this week. Okay? All right, that's algebraic distribution. Okay, so let's talk a little bit about some word problems. And you took a paper home, and if you didn't, just make sure that you can write these down, and you can I'll let you get a copy tomorrow. This is what you might see for word problems. So this one says, find the perimeter and area of Peter's pig pen. Okay, what do you think? I'm going to ask you a question. I want you to respond. What is the first thing I need to do to this picture? Hopefully what you all said was, I need to label all the sides. Now, I'm labeling the sides for the perimeter, not for the area, because what some of you guys did, like previously on previous examples, we were like, well, I'm going to multiply everything together. No, we still only multiply length times width, but when I find perimeter, I need to have all four sides. Okay, so in this case, I would have x plus 9 for the perimeter. For perimeter, I add all the sides. For area, I do length times width. So for the perimeter, I'm going to do x plus 9 plus x minus 2 plus x plus 9 plus x minus 2. And I get 9 plus 14. And don't forget these invisible ones. Remember, we had some of you guys on a prior problem last week. There was a 2x, x, 2x, x, and you said 4x because you weren't paying attention to the invisible coefficients. If you made that mistake, make sure you put those invisible coefficients in there. So the perimeter is 4x minus 14 units. Okay. Now for the area, I need to multiply the length times the width. So that will be, so area is going to be x plus 9 times x minus 2. Okay. Now using whichever method that you prefer, I want you to solve that. So you can use the box, you can use FOIL. Actually, why don't you use FOIL? And I want you to, or algebraic distribution, and I want you to solve this one. Okay, using algebraic distribution, I do the first, which is first times first is x squared. outside ones, outside times outside is minus 2x, inside is plus 9x, last is minus 18. And when I combine these two terms together, I get x squared plus 7x minus 18. And that's how we find the area and perimeter of that one. Okay? I'm going to save this one to do in class tomorrow. And in fact, I'm going to save the rest of these to go over in class tomorrow because they're strange figures and I want us to really talk about them. Please make sure that you have done all of this and looked through it and written down any questions that you have about this. We are going to practice using algebraic distribution tomorrow because you have to practice the process in order to understand it. But once we've practiced it, I want you to use whichever method you feel most comfortable with. Okay, so tomorrow, see you then.